Hello, and thank you all for joining us today for this educational Innovise webinar. My name is Caitlin Nine, and I'm part of the marketing team here in the Innovise Portland office. In this webinar, we will discuss how your team can leverage multiple remote machines to work as a true workgroup application and efficiently return simulations to a single shared location with InfoWorks ICM. For those of you who may not be familiar with Innovise, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in our industry. Innovise offers a library of software programs for the design, analysis, and management of water infrastructure, including workgroup collaboration like InfoWorks ICM, which you will see today. Now, on with our presentation. I'd like to introduce our presenters. Today's presenters are Matt Anderson and Nathan Gertz. Nathan is a product specialist with Innovise. Nathan joined Innovise in 2015 after completing his master's with research in hydrology and sediment loading. As a project engineer with Innovise, he has worked with a wide variety of sewer, water, and storm models, and now specializes in real-time model forecasting systems. Matt joined Innovise in December of 2016 and comes with very valuable experience, especially for today's webinar, as he spent 6 years with Autodesk, most recently as a product manager. He spent over 16 years as a private engineering consultant, and over the past decade, he's been involved in improving the workflows and technology that engineers use to study, design civil infrastructure and water resources. Thank you again for joining us. Would you like to start our discussion, Nathan or Matt?
Today's agenda, is kind of, I want to talk, and I want Nathan to help me present really some of the work group production of ICM, how ICM was built for this collaboration, and some of the new elements of ICM version 9.0 that came out last week. And we're going to do it live, and it's going to be interesting. Just because of locations and how we're connected here on the internet. So, bear with us with that. So let's just tackle the first question for, many of you. Sometimes, what is ICM? If I can get there we go. So ICM is an integrated modeling platform that incorporates really both the urban and the rural catchment, okay? We have hydrology and we have hydraulics, both of the natural as well as the man-made, and we can incorporate both of those into a single model. Okay, but what we've done is leverage some technological innovations to help you as a user manage data effectively, allowing you to build models, view those models pretty clearly, view the results, and eventually, and Nathan's a specialist at this, get into that operational so that your model then can be hooked to forecasts and that. But we can also do remote simulations. We can leverage a pool of computing resources and give that functionality, a reality across a large group. Okay, I mean, this is a product. It's got a long history. It goes back to some of the other InfoWorks CS and RS, but ICM, 9.0, that's been out for a while, is used in a vast majority of the cities and agencies globally. And I think I put a little note from London to New York to Shanghai to San Antonio, Texas, and pretty much everywhere in between. So there's a lot of places. So why do we want to use ICM? Come on, click. There we are. So it's a full integration, okay? Integrated catchment modeling. We do 1D and the 2D mathematical modeling of, the underground, the below ground, as well as the surface ground elements of catchments modeled in one network. You notice the image there, a lot of triangles. It's a mesh model. We can do the hydrology, the hydraulics of those natural and man-made systems. We can leverage scenarios, and we can leverage radar and accelerate all of those simulations with some technology. One of the purposes that ICM was built was to be able to build the ability to scale, okay, from a single user, say me on my laptop, all the way to a full enterprise solution. We leverage that technology. And that's hopefully one of the things that we'll be able to demonstrate today is how do you cost effectively build a single model for that complex engineering challenge and leverage today's current IT technology. So ICM helps you understand it all. So you can look at the stormwater models that can show street flooding and property impact, damage assessments. It can incorporate those river models that can predict inundation and overflow routes. Look at profile, look at 3D views. We can leverage radar rainfall. You can kind of see that in the animated GIF there of radar falling on a model and the resulting results in the hydraulic profile there. We can leverage 3D flooding visuals. So we can tilt the model up, take a look at the flooding results in product. And we can do animations here. So in this case, we can do all of that. And this is one of those things I wanted to pause here on this webinar and talk a little bit about one of our Texas clients, San Antonio. HDR gave a presentation at TFMA in my San Antonio. Their San Antonio Express News had a great news article about what the city was worried about, and they were worried about back in October, November, tasked HDR with taking the city's model, taking the San Antonio River Authority's model, putting all of those models together and say, what would happen if Hurricane Harvey had stalled not over Houston, but over San Antonio? So HDR was able to shift that radar and perform that analysis. And that's one little GIF here, if I can make that animate again, of some of the analysis that they did to give them insight for what could happen. I mean, I think it's an awesome demonstration of the capabilities of the software to be able to shift that and be able to take that model and look at what would happen. Now, if I recall correctly, Bexar County's got 1,300 feet of fall. Harris County and Houston's only got 300. So different reaction to the same radar rainfall events. But these are some great visuals that help, portray the story of what happens with ICM. So we have that ability to make these great visuals, flooding visuals, great animations, help you identify what the risks are, what the damage to those buildings that you see that are flooded right here in the middle of the screen. But we leverage this technology so that you don't have to sit and wait for 14 hours or so like some other products have. We leverage and scale this technology so that laptop, that desktop, maybe a set of server computers can share all of these resources that you may have sitting around the office. With those licenses, you can design and build your work group or enterprise system to leverage all the computing resources you can muster. So just a little animation. I'm up here in Portland, Oregon. We have a ICM controller in Denver in Nathan's home office. That's our work group location. We also have Nathan, who happens to be on the road today. He's in Texas. I think that's roughly where you are, Nathan, in Texas. But I'm going to connect to that work group. I'm going to pull the product down, going to push that up, make some changes. Nathan's going to connect to that same work group, pull those results down, and we'll take a look at some of the new things in ICM that can kind of help that collaboration. So 9.0 came out, I think it was last Wednesday, Thursday, somewhere there that we put it up there. And many of you probably received in a notice email. One of the things that we've noticed is, when you open a model, so for me, opening a model, or actually Nathan will demonstrate this, this aspect, there's going to be a prompt. He'll have a model, he'll open it and realize that, hey, the work group will notify him that, hey, I made some changes to the model. So when we go to run these, because in a work group, I may be changing something, Nathan may be changing something, we may get Carolyn or Caitlin to do something, before I waste those computing resources, I want to make sure I have the most up-to-date model network. And in this case, there's some visual feedback before you run to update the latest. We've also added some user-defined water quality process. We've enhanced that. We've added a growth. I'm not going to demonstrate that today. Radioactive elements, things that are dissolved and attached, and how that works. It's a little bit beyond what I can do. Subsurface control redirection. In this case, we can control what surface a SUD, or best management practice, if you will, what that can actually drain or attach to, rather than the generic percent. As well as we've enhanced the performance. So we've increased the performance of the mesh. I think some of the latest tests of being able to do about 23 million mesh elements in a very reasonable amount of time, as well as being able to open report files, the log files of significant size, and give you some indication that we're not just sitting here locked up. So with that, we're going to go ahead and going to switch over to ICM. And we're going to make sure that we all have that up and running. Okay, so I have ICM, and I just want to I've opened ICM. So I've made a connection to the Denver server, and I know it's a little hard here to see that. And this is the model group that we want to look at. Let me go ahead and make this a little bit bigger here. So I have a model, ICM, Ruskin Gardens. You can see we've got triangles in here. We have building polygons that represent those. Go ahead and open. I'm just going to drag this theme over just to help you see a little bit more what's going on. So we've got subcatchments, connected to manholes with links going there. So it's a pretty standard hydraulics model. We have that ability to grab and check those elements here. I'm going to very quickly, I'm going to switch back, because just to make my life a little easier, I'm going to go ahead and select a couple of pipes here, and I'm going to pull down my links. So I have these links that are here, and I'm going to make a change. Right now, these are 8.9 inches, and I'm going to adjust these for, oops, not what I wanted. Set current value, set new value for self. I want to change these to 18 inches, okay? But I also want to flag these. I'm going to flag these. So I've got a custom flag that, hey, I've made these changes. And in doing that, go ahead and validate. Okay. And then I'm going to then check and commit these changes made by Matt. So when I do that, okay, I've just now pushed those changes off to the Denver server. Okay. And so go back to here. I want to jump and make sure Yep, come on. Make sure I get these. And take a look at, yeah, I've got those grids. I've got that. Make sure I get through my steps before I send that off to Nathan. Yep. Okay, so I've made those changes. I have run this model, and I think I just hid that. I've run this model before I made those changes, so I have some results here on my machine. And one of the things that I'm going to do while I switch over the presenter mode to Nathan is I'll actually, push these up to the server. Right now, this simulation was done my computer yesterday without that 18-inch change. But right now, only I can see these results. But I'm going to want to share these results with Nathan, and Nathan will eventually want to take a look at and push his changes, because he was tasked with some other changes in the model. Push all of those results, because we've got a number of runs, a number of simulations that we're going to want to share. In that case, he's going to want to leverage some of the IT computing power within our corporate network and be able to share that. So, Nathan, you ready to take over?
Yes, thank you, Matt. I'm going to make myself presenter. I will select this. So I should be sharing my screen now.
It's coming across. There it is.
Awesome, great. So as Matt mentioned, I'm actually away from my office. I'm at a user group meeting here in Texas. We're actually looking at some different case studies using ICM. And so I am connected to the same model remotely. I'm unfortunately needing to use a VPN connection to our corporate network, so I'm really not in very ideal connectivity settings. So I guess against my better judgment, but I felt like it kind of fit in with this webinar. So here I have the same model open that we were looking at on Matt's machine. In fact, it's the same copy of the same model. And you might not believe me. In fact, also to make it a little bit less believable, if I open up the properties of one of these pipes, I'm actually working in SI units or metric, just for fun, while Matt was doing things in inches. If you recall, he changed his pipes to use inches, but mine is in millimeters, and that's just something because ICM actually handles all unit changes for you, and you as a user can choose to go with whatever you prefer. You can change the units at any time, and ICM handles those smartly. And so I'm going to make some changes on the same network, and so if also I just want to point out, I had this model open right before Matt made those changes. So this copy that I just opened up doesn't have Matt's recent changes. I selected a pipe that he changed, and it still has an old width and no data flag. If I were to open this up after he made those, it would have the change, but I'm going to intentionally make some conflicting changes here to mine. So I'm going to go ahead and upsize. I actually need to move aside some of my GoToWebinar windows. There we go. So so Matt upsized these upper stream pipes. I'm gonna upsize the downstream pipes and do a little bit of overlap with Matt. And so I'm going to now open the pipes that I just selected. And so here, I'm gonna make a change in metric. I'm just going to set these to be 300 millimeters, however many inches that is. And I'm gonna assign my data flag. So NG are my initials. And a nice thing about data flags in ICM is that you can hover over the data and it will show the data flag. It will also you can see edits by Nathan. And this is a really useful thing when you're working as a team of modelers. You can make changes and do what you need to do, and then make flags so that you can then communicate where the data is coming from. You could also come up with other flags, like wherever you have to infer data where you're not entirely sure on the value, but you're making a best guess judgment. So then you can flag it for needing review later when you get that data. So there's a lot of great applications for these, but for now, I've made my changes. You'll see in my profile, these downstream pipes just got a little bit bigger. These upstream ones are smaller. And at this point, I'm going to commit my changes. Now, if I click the Save button, it will then bring me through the commit changes process, and it will notice that there are some differences between my and Matt's versions of the network. Instead, I'm going to use a little bit smarter practices, and knowing that there's also someone else working on the same project at the same time, before I commit my changes, I'm going to click this Update from Master Database icon. And so it's now committing the changes, but this prompt popped up that says the local network has been updated. However, there are 3 objects with conflicts. That's because Matt had also already made some changes to the same network before I was able to pull those. And so this is how ICM handles cases like this, where you might have someone, 2 different people making the same, making changes to the same objects at the same time, because there needs to be some kind of conflict resolution. And in this case, since we both currently have equal permissions to edit the database, the later person, that's me, gets to choose which values to keep. So, so here we are. You can see that there's an old value. This was the value that before we changed anything. And this is actually a node. Let me go to a conduit. Here we go. So the old value is 225. I upsized it to 300 millimeters. And Matt changed his to 16 inches, which corresponds with 457. And I'm just going to say I'm going to keep my change. And the way how you can do this is you just check a box. So, and whichever value is going to get kept is going to have is going to be highlighted in green. So either I use my change or I just leave it on his change. So I'll leave it on his for now, and I'll say resolve conflict. And there's and so that should be it. So I'm going to say commit now, and make a quick comment so that other people in my team will know the changes that I just made, and I will validate my model. ICM has a nice built-in validation so that whenever you're making changes to the database, it will check for common errors and make sure that the model can be run easily. And this is just to help you make sure that you always have a model that's ready to go whenever you're committing changes. So now if I come back here, one nice feature in ICM is that we can take a look at this commit history. So if I open this, it's just taking a second because it has to pull the commit history from the Denver office back to my machine right now in Dallas. And so here you can see the 2 changes that were made today. Here's Matt's changes at 9:21. That's I'm in Central Time. And then here's my change. And you can see the comments that correspond with that. And this model happens to have history going back to 2007. It's a little bit older model. Typically when you have a larger city model, this history can be a lot longer, but this is really useful when you're working on teams to have an audit trail of what you've done on a model, and especially it safeguards you. It gives you the ability to go back in time at any point that you need. And this is really useful when you're working on teams. If something goes awry and you're no longer matching the calibration, or maybe there's something that's unstable or not running well, you can always go back in time and make an extra copy. You can just click this copy button and go back. So it's a really really key capability if you ever want to be working on a team together. And it is far superior to keeping a file shared on a server that people just download a copy, make edits, then replace that copy. The more manual process that you have to do with other software platforms, this is just a far more robust system. Okay, so that is a quick overview of looking at sharing a model across different areas and committing changes together, working as a team. And I'm going to switch over to running simulations now using shared resources. But first I want to mention that with the work group, so in ICM, you can either use a standalone database. This is going to be the default, which is just a file on your machine, just like other software. But you can also run using a work group. And so this is where I'm connecting to a work group data server. USDEN stands for our Denver office. And so here we have a few databases here that we're both connecting to. Now, we actually recommend as InfoWise that even if you're working by yourself, it's worthwhile to use this work group capability. If for sure, it's far better if you have a team of modelers. Definitely use work group rather than standalone. But even if you're by yourself, we recommend using work group. So I actually have a work group data server running on my local laptop, and so I can just connect to that right here, local host. And I actually organize all my different models right here on a workgroup data server. And I found that it's a lot easier than having a C drive with files all over the place. So here I have my presentation database. I've got a number of different models here. Probably whenever you learned ICM, you may have gone through our training or you've gone through some tutorial models. It can be useful to have just a place where you store your different testing and training models so you can always go back to them for training. And I also help on our support team, so we get various models and I do projects. And I found that this is just really nice way to organize everything rather than having things stored in folders and then I have to keep track of which version each database is on, and you just end up having multiple copies of things and it gets to be a little bit messy. So I found that it's really nice to use this workgroup data server, which is free if you have ICM. So I'm going to jump into this database now, and I'm going to run some simulations using shared resources. And again, in a master database, you can actually have quite a number of different models. So here I have a couple different, an ICM Live, a Swim Live model. You could also have InfoNet models all mixed in with your ICM models. And here I have different example models here, a treatment plant, a dam break, different fun things. I'm gonna open up the same model that we had just a little bit ago. So this is the model we were looking at. It's a 1D, 2D network. I'm going to open up some results. Just before I start running things. So here we have, just a pretty small little 1D system that the manholes will overflow onto the streets. In the streets, we have a smaller mesh size, so we're using higher resolution. Then water is flooding and going down the streets. It can then re-enter other manholes and re-enter our underground sewer system. You'll see elsewhere water is now overtopping the curb and running in between these houses, which are currently modeled as voids in the mesh. So this is just a typical example of some results. And so now I'm going to run the simulation in a few different ways just to illustrate some different capabilities. And I'm going to choose this six simulation run. So if I open this up, one of the new features is this update to latest icon. It's now boxed in red. So in version 9.0, it will detect if you're not using the latest version of the network, and you can now update to latest. And so now I just clicked that and it pulled the latest version. I'm also going to just drag in this rainfall profile that has 6 events built into it. Let's see, I probably don't need that kind of time step multiplier. So now I'm going to rerun this simulation. And currently I'm just using a standalone, like the default single computer methodology. So I'm going to run it on this computer and it's going to queue up 6 simulations. And this is the default. So here we see simulations, the six of them showed up. They initially started pre-processing. Now the first one is done simulating. I can click here. I can kind of see the progress over time. And these are just simulating one by one in a series, which is the default process. And then the results are being saved on my local computer. So that's the status quo. Now I'm going to do the same thing, but I'm going to update things a little bit. So here, I have my local agent, and agent is, I guess, kind of a funny term, but essentially we came up with some terminology so that every machine with ICM has what we call an agent, and then the agents can talk to each other so that I can talk to other machines. So now I'm going to switch to a workgroup setting, but I'm still just going to keep things local. So I'm just going to use my computer as the coordinator. I might mention that later. But here on the agent options, I'm going to now allow 3 runs simultaneously. And I'm going to save. And so now I'm going to rerun the same simulation using that new setting. And I need to click on arrow here. There we go. So I'm just going to reopen this simulation, rerun simulations, and now still leaving it on this computer. Since I switched to a workgroup setup, now I actually have the option to store results either locally or I can store the results on a server. This would mean that once I run my updated model, then Matt would be able to also access the results in Portland. So I don't have to run results and then he runs results. We can just share the results on a server, and then ICM will just handle the files. So for now, I'm going to leave it locally. And so now I've queued up another 6 simulations, but you'll see now 3 of them are simulating at once, just as I specified. And they are now finishing up. 3 at a time runs a little bit slower than 1 at a time, but you'll see that running them in batches of 3 is definitely faster than running them in series 1 by 1. And that's the case for this model. It's not always the case for every model. But there we go. I was able to just use my, on this laptop, I just have an i7 processor. So it's good, but nothing outstanding. Now I'm going to take things a step farther, and I'm going to run using a pool of computers. So I'm going to load my local agent. And now I'm going to say use the coordinator on this US Denver machine. And the coordinator is essentially just a term where we nominate one of the agents to be a coordinator. So that means, to put it in our lingo, the local agent on my machine talks to the coordinator, which then can serve out jobs to other available agents. So essentially, I'm also going to make one other change. There we go, and I'm going to save. So now you'll see several other computers just showed up in my connected pool of resources. And that is pretty cool, because now I'm going to, instead of running 6 simulations, I'm going to go ahead and run 25 events. And I have just one design rainfall ensemble of 25 events. I'll click update to latest. And now I'm going to say run simulations. And here I can choose, rather than just this computer, I can choose any one of these different computers. And in cases where I've allowed a computer to do multiple simulations, you can see this one has 5 free slots, others have just 1 free slot. And I can also group them, so I have priority machines for remote simulations. In this case, I'm just going to choose any computer and click OK. So in this case, there's a little bit of a slower process here in that I am running from Dallas on a VPN to my corporate network. So then my computer is uploading results to Denver, and then simulations are getting assigned to available computers. Now this actually runs a lot faster if I am in Denver, because we don't have to wait for this uploading process, which is currently a choke point. But you can see the advantage that there's multiple computers being used all at once. And it feels, it's pretty powerful that, here I can be out on a business trip, and let's say I want to just quick, rerun a whole large batch of simulations. I can just click run, and I don't have to give up any of my CPU on my machine, so I can continue doing what I'm doing. And actually, one other thing I wanted to mention on these simulations is that, let me make this window smaller. So here on 2D parameters, we can actually ICM can, by default, runs things on the CPU, just like all typical software, but also ICM can detect if you have a suitable graphics card. Now, GPU is found to be very much superior for simulating large numbers of small calculations, so it lends itself really well to 2D. And so what ICM will do, if you have a good GPU card, is that it will run the 1D network, so all your pipe system, it will run that on CPU because that just lends itself better for that system of equations, while the 2D will then be pushed to the GPU. And so you're going to be maximizing all of your available resources, and the two will be communicating at each time step, so they're fully coupled, and you'll be using all of the capabilities that you want. In this case, I was running a pretty small 2D model, so in this small of a model, the GPU didn't actually make much difference, so I didn't bother turning it on. But yeah, I just wanted to mention that ICM can run your mesh on GPU, and if you have a large mesh, like we've been seeing larger and larger models being used around the world, which is why we had to recently upgrade to be able to handle 23 million mesh elements. On that size of a model, GPU is going to be very important. Some tests have trimmed it down to 10% of the runtime. It varies a bit from model to model. But yeah, so that is GPU running simulations on multiple machines. One last thing I wanted to mention is this results manager. This is not a new feature, but it's one that's often overlooked. I actually didn't know about it until recently. So if you right-click on a model group where you store all your results, the results manager lets me see all the different results, and I can see where the results are stored. So these are the different runs, and I can select these, and you can see that these are currently stored on my local machine. That would mean that Matt can't access the results. So if he expanded this group, these would be grayed out. But if I wanted, I can just right-click on these, and I can say move results to the file server. And now they have been pushed. They are being pushed to the file server. Actually, I meant to, sorry, let me redo that. I found that it didn't work very well in this case when I'm remote on a VPN. I meant to be using this agent as the coordinator. Okay, and so now I can I can push any results to the server, and it will happen pretty quick. So now they are getting moved to the server, and so that means that results are going to be shared on a server location so that anyone can access the results, and that's pretty useful. In fact, if I were to see results that were on Matt's machine only, I could then also pull them to the server so that I can get the results without having to rerun the simulation. And with that, I wanted to mention one last thing. If I switch over, I actually have also InfoWorks ICM version 8.5 also open at the same time on my machine. And so in ICM, you can have multiple versions installed on the same machine. You can even have them running concurrently. And so on 8.5, oops, here we are. It's this one. They have the same icon, so it's a little bit confusing. But I can have a database in an older version, and the thing I wanted to illustrate here is that in this case, I'm actually going to connect to a group of computers that are actually over in the UK. If you attended a webinar about a month ago by Andrew Walker, he gave a better representation of the capabilities of ICM because he ran a group of simulations from an office in the UK, and he ran them using this large group of computers. I'm going to do the same thing, but do it from Texas. And so it's going to be a little bit slower, but it can be run. So I'm going to just say run. And here you can see different computers, and UK Wall stands for our Wallingford office in the UK. And so I'm just going to say run. And now things are being queued up, and I'm actually running simulations on the other side of the Atlantic Ocean. It's albeit a little bit slow to upload results that far, but these machines are very capable of handling things. So the capabilities are quite powerful. I just wanted to show that, and that wraps up my part of the presentation.
Yeah, Nathan, we've got a number of questions that have been going on here. Anything that stands out, Nathan? It looks like most of these have been asked and answered publicly, so couple of good questions.
Yeah, it's a kind of long questions, hard to read quickly. But I think I see some questions about operational modeling, which might be like an ICM Live type case where you have a model that's running and passing states from one simulation to the next. I don't know if I fully understand the questions, but yes. So ICM Live would run on a frequent basis and just update and pass the state from one simulation to the next, so that every hour you're just using the previous run. And if you needed to change that, you can then just manually run a simulation with the changed model, and it will just start picking up a new state files from there for initialization. Yeah, I guess that's kind of a loaded question. So I'd be happy to chat afterwards about that if you're interested.
Cool. Yeah, Nathan, there's a question here at the end. In the results manager, if there are sims saved locally, can the group still view them and upload them to the main database? And I think that's what you covered, which is in that results manager, you could see the results that stored locally, not stored locally. In fact, when we did our rehearsal, I was able to actually see Nathan's results that were stored locally on his machine, and I was able to actually force I don't know what, not a push, but a pull, to pull those off of Nathan's machine and store those in the work group, so that I could actually begin to look at those results. So yeah, it is available.
Yes.
So, and then there are a couple of other questions about branching of models and things like that, and I think that is applicable to scenarios, and we've got a pretty healthy scenario manager. We didn't cover that today, but when you want to take a model and test a different scenario, test that, my changes, if you will, those can be handled in that case. So that's I think should be able to cover that. Anything else to add with scenarios there, Nathan?
Nope, but yeah, scenarios can share inheritance from a base network, so they can be a really useful, efficient way of managing your data to handle different copies of the network.
Yep. Cool.
And yeah, one thing on the simulation manager, when you have a number of tasks all being queued up, if you have like long 2D simulations that might take a while, you could end up with a long queue, and it's really easy to pause or cancel simulations or reorder the priority. So that can be a helpful feature.
Yeah. Here's a good new question here. How to convert a standalone model into a workgroup model?
That's very really easy. I would just copy it into a transportable database and then create a new workgroup database and just paste it right in there. So real easy. Creating a workgroup, you just install the workgroup data server. It's a light installer, and then you can just route to it and just create a new database, and that's behaves just like a standalone database essentially.
Cool. Can you how about rights, administrative rights?
Yeah, so in a master database, you can assign permissions so that only certain people can have access to the database. And this is going to be based on your Windows login. It's really easy to use, and you can have people with full database owner permissions to make edits. You can also have read-only users. And you can also assign some local permissions based on model groups. So maybe you might want to have someone has permissions on one project, but not the master copy of the model. So there's a bit you can do with permissions.
Yep, cool. So is the master database saved on a local machine or in a server? And in this case, you know, the master database that I connected to is on the server, and I pull a local cache, which is kind of why you can see that icon that there is, you know, when we went to run it, that there was an updated version, and had I demonstrated the physical opening of a network, it's going to check the commit history on the server and say, hey, Matt only has commit history to, you know, version 11, and, you know, Nathan has checked something in and we're at 14 or 15. So that's one of the things that 9, we've given that ability to, you know, to check to make sure that what's sitting on my laptop or what's sitting on Nathan's laptop is up to date, you know, because you don't want to get into a situation where you don't want to run something without the latest. So, cool. Yeah, let's see. Some good questions here popping up. So,
I see a little bit on just shared or conversions from ICM to ICM Live, or with ICM SE and so on, and they all are. Our software treats them all pretty much the same. So you can have your ICM Live model in the same database as ICM. So you can actually have ICM Live based on the same copy of the same network. So you don't really have to do any conversion process. You just connect your existing model to new live data connections. So there's really hardly any conversion process at all.
Yeah, it's more licensing.
Yeah, exactly.
Exactly. So cool. All right. With that, I think that covers most of the questions for myself and for Nathan, Carolyn, and Caitlin. I want to thank you for attending and joining us at this morning's webinar. That's my email address. That's Nathan's email address. Please feel free, you know, send us questions. We'd love to hear from you, including, you know, if you happen to have any suggestions for webinars in the future. You guys have lots of great ideas, and that, you know, helps us solve those problems. We can do these webinars. I enjoy doing it. Nathan, I want to thank you, and thank you all again.